Alright, in this video I'm going to do Unit 2 Topic 1. I probably won't do all of the problems in this video because it is a long topic. So number 42, they tell you that DE is parallel to BC. So I'm going to mark that. Please don't get confused. DE is not the midsegment of BC. They never mention that D is in the middle of BA or that E is in the middle of AC. So it's not midsegment, they're just parallel. Okay? They tell me that CE is twice the length of AD. Alright, so if AD is X, then CE is 2X. So look, I just made AD X. We don't know it. So CE would be 2X. They did tell me AE. AE is 8, so I'm going to put an 8 there. BD is 9, so I'm going to put a 9 there. And BC is 18, so I'm going to put an 18 right at the top. Alright. So there's the setup of the problem. Part A says, prove that the triangles are similar. So they want me to prove that the small triangle right here is similar to this big triangle right. So, alright, so we have those two triangles, and they are in fact similar. The reason you know this is because if the lines are parallel, there we go. If the lines are parallel, you know that these angles are congruent because of CAP, corresponding angles, and you know that these angles are congruent because of CAP. Alright, so I'm going to say it's given that DE is parallel to BC, and angle B is congruent to, instead of saying angle D, I'm going to use 3 letters because there are 2 angle Ds, so I'm going to call it ADE. Because of, I say cap, but if you write corresponding angles, because that's what your teacher taught you, that's fine. And angle C is congruent to angle DEA. Notice my E is in the middle because I'm talking about angle E. Also because of cap. So the two triangles are similar. Triangle ADE, and I mean they told me the letters that match right here, so I'm just copying this. It's similar to triangle ABC because they have 2 angles in common. So this is AA. Angle is used to show that 2 triangles are similar, along with SAS and side, side, side. You cannot use AA to prove that triangles are congruent, however. So part A is done. I proved that the 2 triangles are similar. Now that they're similar, when triangles are similar, you know that all the sides are proportional and all the angles are congruent. So they're asking me to find the length of AC. So they're asking me to prove, or no, to find X, basically. So there is something called the side-splitting theorem, which says that this divided by this equals this divided by this. Alright? So you just write exactly what you see. Pretend there's a fraction between the 9 and the x, and a fraction between the 2 and the 8. This is the easiest way to do this problem. There are other ways, but this would be the easiest. So I'm just going to write that 9 over x equals 2x over 8. So side over side equals side over side, and cross multiply. So you have this diagonal right here, x times 2x. So x times 2x equals, well, you know that, for example, 4 times 4 equals 16, or 4 squared. So x times x equals x squared. So x times 2x equals 2x squared. That's kind of a tricky problem. And then 9 times 8 equals 72. All right, you want to get x squared by itself, so get rid of that 2. And 72 divided by 2 is 36. And then to get rid of a square, we take the square root. And we know that the square root of x2, those cancel, so it's just x, and the square root of 36 is 6, so x equals 6. So this is going to be 6 here, and this is going to be 2 times 6, which is 12. Alright, so determine the length of AD, AD equals 6. Determine the length of DE. Okay, oh goodness. Alright, so DE is this one right here. My picture looks like a mess. Okay, so if you want to find DE right there, I'm going to draw the small triangle, which has a 6, an 8, and a Y. And I'm going to draw the big triangle, which has a 18, a 9 with 6, which is 15, and a 12 with 8, which is 20. And I know the two triangles are similar. So I'm just going to set up my proportion. I know Y has a partner, and it's 18. And 8 has a partner, and it's 20. And I don't need another partner. So Y's partner is 18. 8's partner is 20. I put this triangle on top. And I'm just going to cross multiply. So I'm going to do 18 times 8 and get 144. And then divide by the leftover 20. Divide by 20 and get that Y equals 7.2. So DE equals 7.2. Decimals are your friend. They are just fine. So there's number 42. All right, let's do a couple more. Number 43. You can see right away, these triangles do not look congruent. They look similar. They don't look the same. All right, so they're probably going to ask me to do some similar stuff. So which similarity postulate may be used to prove that the triangles are similar? So I can see right away that they have a vertical angle. All right, so that gives me an angle. 20 goes with 40. So that looks like a times 2. And then I want to make sure that this one is also times 2. 25 with 50. I know that scale factor is also 2. So it looks like it works out. You have two sides that are proportional and an angle that is congruent. Remember, sides are proportional, angles are congruent. So which similarity postulate is this? It's side, angle, side. Right. B, what's the length of the pond? So I'm going to put an x here. I don't like other variables, so I'm just going to put an x there and solve for x. That's fine. So it looks like the scale factor was times 2. So all I'm going to do is multiply 30 by the 2 and get 60. So I know x is 60. Now, if it was a more complicated number, then you could just set up a proportion. So I'm going to make this triangle on top. So, for example, 20 on top, its partner is 40. And then the 30, this 30 on top, the partner is x. And then I'm going to just cross multiply. So 40 times 30 is 1200, and then divide by the leftover 20, and you get x to be 60. So that's another way to get x equals 60 if you were dealing with more complicated numbers. All right, let's do another one. Number 44. Oh, yeah. All right, so if you have, let's say, I always use my 90, 60, 30. So let's say that's 90, this is 60, this is 30, and then you have a mini-me version. 90, 60, 30. Obviously, these triangles are not congruent. They are similar by AA. So you can look at the sides. Are the sides congruent or proportional? And the correct answer is proportional. And then the angles are congruent. 60, 60, 90, 90, 30, 30. Okay, so that's how it works for similar figure. All right, let's do one more before I end this video. Number 45. In the figure below, the small triangle is similar to the big triangle. So we know that they're similar. So if they're similar, we know that the angles are the same. So I know that this angle and this angle match, and this angle and this angle match. And I also know that Q matches with itself. That's reflexive. All right, part A. prove that lines are parallel, whenever you're proving that lines are parallel, you have to use the converse of something. So it might be converse of corresponding angles, alternate interior, I don't care, but it needs to be a converse of something. So I want to prove that this line right here is parallel to this line, which they are, and I'm going to use the converse of these angles. And these angles are in the same spot, so it is half. All right, so let's do a quick proof. We were given that the triangles were similar. So then I knew angle 1 was congruent to angle 2 because they were similar. And therefore, RS parallel to CU by the converse of half. Okay. Alright, and that should do it. B, right? All congruence and proportions between the sides and angles in the triangle. Alright, so you know that angles are congruent, so angle Q goes with angle Q. Angle R goes with angle T. And I'm just looking at this right here. So I can see that T, or R goes with T, and that angle S goes with U. Alright, proportions. QR is proportional to QT. Sides. So sides aren't congruent, they're proportional. What else? I know that RS is proportional to TU. And QS is proportional to QU. Alright, let's do one more. 46. And then I think the video will be too long, so I'm going to stop at 46. The figure below shows triangle BCD, triangle B prime C prime. B prime will be the image of triangle BCD after a dilation with a center B and a scale factor of 5. Okay, so I want to multiply everything by 5. So I could imagine that BCD is going to look really big. 5 times bigger, like that. Okay? So, answers. The point B prime will be the same point as, so my B prime will be here, my C prime will be here, and my D prime will be over here. So B prime and B would be at the same point. Alright? C prime D prime will be what with CD? Oh, it looks like, if you look, CD and C prime D prime will be parallel. Same with B prime C prime. Never mind. So here's B prime C prime. And here's BC. Okay? So they're going to be on the same line. They're not the same size, but they're on the same line. Will be on the same line as. Alright. And 46D, the perimeter of B prime, C prime, D prime will be how many times the perimeter of BCD? It will be 5 times because the scale factor is 5. Alright, I will put out a second video soon.